Okay, and guys, I apologize. I'm going to just start again so that it records all of this business. Okay, my bad. We're going to find P of 3 when P is 90. Okay, so y'all, let's do a couple of things here. We know that our X number is 3. We know that our P number is 0.90. We need to find our Q number, y'all, which is 1 minus P. So my Q number should be what, 0.10? Okay, y'all, I'm going to use the formula that I have right here. P of X equals P times Q to the power X minus 1. And y'all, we want to find P of 3. So we're going to say, what's our value for P? 0.90. Okay. What's my value for Q? 0.10 to the power X minus 1. Our X number, y'all, was 3. This is going to be 3 minus 1. But we know that 3 minus 1 is the same thing as what? 2? Okay. Y'all, I'm just going to do this on my calculator. There's no formula. There's no like special thing I need to do. I'm just going to put 0.90. Okay. And then right next door to that, I'm going to put 0.10 to the power of 2. I'm just going to hit my little square button and hit enter. And y'all, I'm coming up with 0.009. Okay, so just a very straight plug and chug problem to figure out how to use the formula, okay? So now let's do this with a little bit of context. So y'all, I apologize because the author of the book is using some old people because Chauncey Billups has not played in a very long time. But it says basketball player Chauncey Billups of the Detroit Pistons makes free throw shots 88% of the time. Find the probability that he misses his first shot and makes the second. Okay, let's find a couple of things here, y'all. Let's find our value of P. P is the probability that he's going to make the free throw. 88% as a decimal, y'all, would be what? 0.88. Now, let's find our value of Q. Remember, y'all, Q is always 1 minus P, right? So if we were to say, what's 1 minus 0.88? 0.12, right? So again, if he makes his free throw shot 88% of the time, that means that he misses it 12% of the time, right? Okay, y'all, I'm going to use my formula. We're going to say P of X equals P times Q to the power X minus 1. Now, he misses the first shot, so he doesn't make it until which one? The second. Y'all, that's telling me that X is equal to 2. X is going to be when does he actually make, when does his success occur? He missed the first free throw, but he made the second. So look, y'all, we're going to find P of 2. We're going to take 0.88 times Q, which was 0.12 to the power 2 minus 1. But again, we know that 2 minus 1, same thing as 1. Okay. So y'all, I'm going to take my calculator and I'm just going to go 0.88 times 0.12 and do the little power of 1. Y'all, by the way, you don't have to do the power of 1. Power of 1 is the same as what you already got, so it doesn't really change it. Okay, y'all, I'm going to go ahead and go to 3 decimal places. What do you say, 0.101? And there we go. And that's what basically a geometric distribution is, okay? Did we do okay? I'm sorry. Oh, 106. Sorry. Yeah, why did I say 101? Sorry. Sorry. My bad. Boom, 106. There we go. 0.106. Excellent. Okay, so y'all, that's all geometric distribution is, okay? It's a pretty simple process. And the last one, y'all, that we have is something called the Poisson distribution, okay? So let me tell you a little bit about the Poisson distribution, okay? It's a discrete probability distribution of a random variable x that satisfies, there's 3 conditions, y'all. It says the experiment consists of counting the number of times x an event occurs in a given interval. The interval can be an interval of time or area or volume. I think for the most part, y'all, we use time. The probability of the event occurring is the same each time. And the number of occurrences in one interval is independent of the number of occurrences in other intervals. And the probability of exactly X occurrences in an interval, and they give us this formula here. And y'all, I'm going to show you how we're going to do the problem. We're going to do one that's going to be straight plug and chug, okay? Just again, to get some familiarity with how do I use the formula, okay? So y'all, first thing I'm going to do for this problem, I'm going to copy down my formula right here, okay? P of X equals mu to the power X e to the power negative mu divided by X factorial, okay? That's the little exclamation point. Okay, y'all, a lot of this stuff is going to be done on our calculator, but I'm going to show you how to do this. So y'all, they gave us a couple of values here. Mu, remember y'all, mu is just an average. So they're telling us the average is 15, and we want to know what happens when X is equal to 7. So y'all, this type of a problem is going to be very much calculator problem. We're going to go, what's the probability of 7? We're going to say our value of mu was 15. So we're going to go 15 to the power of 7. And I'm going to show you how we're going to do this little e business on my calculator. But we're going to go e to the power negative 15, all divided by 7 with the little exclamation point. Okay. Let me move that over here just so everybody can see it a little bit better. 7, boom, with the exclamation point. Okay, y'all, I'm going to put all this business upstairs in parentheses. Okay. Now let me walk you through the process, y'all. And get my calculator. Let's clear everything out. Let's open up a set of parentheses and let's open up another one. Let's get 15 and let's raise that, y'all, to the power of 7. Let me close my parentheses first. Sorry. Boom. Raise that to the power of 7. Okay. Right next to that, y'all, I need to get to this e business. Y'all, the way I'm going to get to the e business is I'm going to hit my second button. And if you look on your calculator, y'all, right above the little button right here next to the 4 that says ln, there should be a little e. Now, it actually opened up parentheses for me, okay? Y'all, and by the way, in your calculator, if it didn't open up parentheses for you, go ahead and open up some. Now, we want to do a negative 15. Y'all, I don't want to hit the minus sign. I want to hit the negative. My negative button, y'all, is down here. Negative 15, okay? Now, I'm going to close those parentheses, and that's just closing the parentheses on my power. I'm going to go ahead and close my parentheses at the end again. Now, I'm going to hit divide, and I'm going to hit 7, and I'm going to go to my math button, y'all. I'm going to go to the PRB, and I'm going to hit number 4, okay? And now, y'all, I'm just going to hit enter, and again, y'all, I'm going to go to 3 decimal places, and I'm coming up with what, 0.010? Yeah, let's do it again. So, guys, I want to make sure everybody's good with this stuff. So the first thing I'm going to do, I'm going to open up 2 sets of parentheses, and I'm going to hit 15, close that off. I'm going to get to my little power button right here, and I'm going to do 7. And then I'm going to get to my E. The way I get to my E, I'm going to hit the second button and then the button that says LN, because if you look right above the LN, there should be a little E. Now, when I do that, y'all, my calculator opens up a parenthesis for me. So I'm going to type in a negative 15. By the way, y'all, this is my negative button. If I hit that one, it's not going to work. So I'm going to go negative 15. Now, I'm going to close those parentheses that it opened up for me, and I'm going to close my parentheses again, and I'm going to hit divide. 7, math, we're going to go to our PRB, and we're going to hit number 4. And I'm going to hit enter again, and we should all be good. Is it working? Did it work for you? Okay, let's take a look. Okay, so let's try this. So let's go parentheses 15. Close it off, raise to the 7th. Now we're going to go second LN. So see how yours didn't put up parentheses? Mine did. Let's go ahead and open up second. Let's go negative 15. Oh, you know what? 15. Raise to the 7th. Okay, then let's do this.
So I hit my little right arrow. Now let's go second LN. Let's go ahead and go negative 15. Close that off. Close that off again. Now 7. Yeah. We're being 4. So, sorry. So sometimes I have to use in your calculator, you have to put that little right arrow so that you don't stay as an exponent.
You're welcome. Okay. So, y'all, I just got a couple more problems to do. I'm going to come back and do this one in a second. I want us to kind of get the idea of what does the Poisson distribution kind of talk about. So I want you to look at, I'll come back and do this one about the fire station in a second. Look at this one here. It says a car towing service company averages 2 calls per hour. So y'all, just to give you an idea, when I start doing something like this part right here is telling me what my value of mu is. The little funny looking U, that's my average, okay? So it says a car towing company averages 2 calls an hour. Use the Poisson distribution to determine that in a randomly selected hour, the number of calls is 6. This is just telling me all that my X is going to be equal to 6, okay? Now, again, y'all, we had that funky formula that we just used right now. Again, one of the cool things about the calculator is we have a shortcut, right? The shortcut works really nice. So y'all, notice how I'm going to do this. Again, I'm going to come back over here. I'm going to clear everything out, okay? Y'all, the way I'm going to get to those Poisson distribution or binomial distribution, I'm going to hit second. I'm going to hit my button that says vars. And I'm going to scroll down until I find the one that says Poisson PDF. Boom, there it is. On my calculator, it's my choice B. Again, it could be different for yours, but you're looking for this Poisson PDF, okay? Okay, so y'all, what we're going to do here is we're going to look for, we're going to look for our Poisson PDF. We're going to put our mu button, which is 2, and our X value, which is 6. So I'm just going to hit 2 and 6, 2 comma 6, 2 comma 6. Boom. I'm going to hit enter, and my probability is 0.12 or 0.012, I think. Yeah, 0.012. That's all I got to do to find my Poisson distribution. It's pretty simple to do, y'all. These little tricks, these little kind of features on the calculator, really nice, because otherwise, y'all, I would have to come back and I'd have to use this formula. So I would say my average was 2 to the 7th, e to the negative 2 divided by 2 factorial. I'd have to go through that process every time, okay? Look, let's try another one. A statistics professor finds that when he schedules an office hour at the 10:30 a.m. time slot, an average of 3 students arrives. Y'all, that's telling me my mu. My mu is 3. Use the Poisson distribution to find the probability that at randomly selected office hours, no students arrive. Y'all, what would be my value of X here if it's no students? 0. Very good. So look, y'all, we're going to do the same thing. We're going to go Poisson PDF. We're going to say our average is 3, and we're trying to figure out what happens when nobody comes by. I don't know. Let's see. I'm going to second enter. I'm going to change this guy from a 2 to a 3. I'm going to change that 6 to a 0. I'm going to hit enter. And y'all, I'm coming up with 0.050. 0.050, right? Again, y'all, how do I get to the Poisson distribution? Let me clear this out. We're going to go second vars. You're going to scroll down. Oops, right here. Poisson PDF. And then you'll enter your numbers in, okay? So y'all, I got one last problem, and it's this one over here. And it says a fire station receives an average of 0.55 rescue calls per day. Use the Poisson distribution to find the probability that on a randomly selected day, the fire station will receive fewer than 2 calls. So y'all, if they're going to get a call, they either, when they're getting their calls, they can get no calls or one call or two calls or three calls, so on and so forth. If it's fewer than two, what numbers are smaller than two? Very good, my friend. 0 and 1. So y'all, we're going to do this twice, okay? We're going to come back over here and we're going to say, look, we're going to use our Poisson PDF, okay? Remember, y'all, my mu in this case is a 0.55. We're going to do this 2 times, y'all. We're going to do it once when x equals 0. We're going to do it once when x equals 1. So we're going to go like this. 0.55 was 0. And let's figure out what we get. Okay. So 0.55 comma 0. And that number, y'all, if I round it to 3 decimal places, what do you say, 0.577? Right, 0.577. And then, my friends, I'm going to do this again at 1. And I'm getting 0.317. And now what I'm going to do, y'all, is I'm going to add these folks together. So 0.577 plus 0.317 equals, and I'm coming up with 0.894. Sorry. Here we go. 0.894, yeah. And we found our probability. All right, so y'all, chapter 4 was about discrete probabilities, right? Discrete probabilities meaning what's the probability that this happened 3 times, 7 times, 5 times or more, less than 6 times, right? That's what we were doing in chapter 4. Like I said, y'all, next week we're going to review on Tuesday. Let me stop recording.